Left justify. So method header. It's a method that takes a string as a parameter and returns true if that string has an even number of characters in it and false otherwise. So it's going to be a method. We're going to return a Boolean. That's true or false, right? The return type is going to be a Boolean because I'm returning a true or false. We're going to go ahead and name the method whatever you want. Has even chars or something like that. And we'll take a string s as a parameter. All right, so that's the method header. And we want to return true if s has an even number of characters in it and false otherwise. How many characters are in s? How many characters are in s? S dot length number of characters. So we'll return s dot length mod 2 equal to 0. So s dot length is going to be the number of characters inside of s. So that'll be a number, an int. We will take that number, we'll divide it by 2, and if the remainder is 0, that means it was an even number of characters. So this would boil down to true, because this is a Boolean expression. Make sense? Similarly, you could have said, if s.length mod 2 is equal to 0, then return true, else return false. You could have done that as well. All right, so this one should have been a pretty easy one. Go ahead.
So if you did the second one, okay, you don't include return statements in your in the same line, right? It would go.
Do you want me to do the if statement version of this?
Could you show me?
Yeah. I'll just delete this line. So I might ask the question, if s.length mod 2 is equal to 0, if that's a true statement, return true. Else return false. Exact same logic. This says, if this is true, return true. If this is false, return false. That was kind of what we were talking about last time about that logic being redundant. It's not wrong, just redundant. Okay, how many people got the quiz right? How many people horrifically bombed it? Okay, give me some explanation. Why did we horrifically bomb it? Starting point here. Whenever you're solving a programming question like this. So this is almost like, remember in those math classes when you have word problems? You kind of have to, there's like a strategy for going through the word problems. Very first thing you should have done as you walk through this, forget about the programming logic in the middle. Don't even worry about that aspect. Write your method header. Write a method. So as soon as you see the word method, you know I need to write one of those guys. And what's a method? Remind me what a method is. We could make it another quiz. Go ahead. That would be a synonym from an older language. Function would be a function is like a method, yes. Specifically, what's a method? Why do methods exist? What is their purpose? Go ahead.
To accomplish a task, so it's a reusable chunk of code that accomplishes a task.
Yep, a reusable chunk of code to accomplish a task. All right, so we're going to write a method. So we're going to write this reusable chunk of code to accomplish a task. And we should know that the syntax for a method is return type. So that guy's our return type. Method name, opening parenthesis, comma delimited list of parameters, closing parenthesis. Is it possible to have a method that takes no parameters? Is that allowable? Yeah, we can have a method that takes no parameters. A good example would be the length method of string. Doesn't need any parameters to work, right? All right, so the very first thing I would do in a question like this is to write the structure of the method. Okay, with this, you at least have some competency credit. The logic in between might be garbage. We haven't put anything in there yet. But we're going to write a method, so methods look like this. The method's going to take a string as a parameter. So that's why we put a string s inside of our parameter list. We can call this string elephant if we want. Name the variable whatever you want, but in our parameters, this guy's going to take a string as an input. I didn't specifically tell you what to call the method, so give your method some sort of name. Has even char, so you could just call it quiz method, whatever you want. Okay? And then the opening and closing curly braces. So this is what you should have started off with on the assignment. Go ahead.
Would you actually need the static keyword in this case?
It wouldn't make a difference because I didn't actually ask you to call it. Right. So whether you put static on the front or didn't put static on the front is inconsequential because static dictates whether or not this is a class or an instance method, which tells us how we're going to call it. So it's not right or wrong in this for this particular question. If I were to then ask you to call the method, because you only know how to call your own methods that are class methods, you probably would have wanted to put the static on front of it. That way you could say driver dot has even chars or whatever you named your class. All right, so static would be optional here in the case of writing a generic method.
But you need Boolean?
You absolutely need Boolean because every method has a return type, 100% of them. Methods that don't return anything have a return type of void in front. Okay, but this guy does return a Boolean. How do we know? Because I say that this guy should return true if the string has an even number of characters and false otherwise. So it's going to return a value of true or false, and we should be able to identify those kind of values as Boolean type. Boolean values are true or false. Make sense? So that's why the return type is Boolean. Definitely need that.
Can't you tell it to return if a value is like 0 or a value is 1? You can tell it to return true or false based off the int, and then you wouldn't need Boolean. Because if you have...
Say this a little more.
Okay, so you don't... Let's say you just do an if statement where you have it doing a loop, and then you have it if the length is divisible by 2 and it equals to 0, then you could print out true. Or if it's equal to 1, then you
Printing out true is different than returning true.
Okay.
So I'm not sure you just even explained the question you were asking. I'm just throwing those 2 cents in there. Remember, we really looked at that as displaying something is very different than returning something.
So like you could return true or return false.
Correct.
And would that mean that you need the Boolean statement because you're?
But this isn't a statement. This is us telling Java what kind of value this method will boil down to.
Okay.
That's required. If we're going to have a return true or return false somewhere in our code, we better have Boolean out there in front.
Okay.
Every single method requires a return type, including methods where you're not going to return anything. It may be a method you're just going to display something. Then you let Java know, I will not be returning anything by putting the word void there.
Okay.
You always, always, always have a return type. Make sense? So now the history connection, you mentioned it's a function. So functions are from a little bit older languages. All object-oriented languages call their functions and procedures methods. Kind of they just did a catch-all with this word method. Some methods return a value, some methods don't. Methods that don't return a value have a return type of void. Procedural languages, which predated our object-oriented languages, they often made a distinction between methods that returned a value and methods that did not. So in those older languages, functions returned a value, procedures did not return a value. More of a history lesson. And then before that, we had subroutines. They weren't even called functions and procedures, they were called subroutines. Make sense? So, but at the end of the day, I would say all those things are basically synonyms for each other. You know, having that knowledge that functions return a value, procedures don't, really doesn't do you any good in today's world because today everything you use is going to be an object-oriented language. and they're going to return a value. And anything that you use that's not an object-oriented language is going to be an interpreted scripting language, which may not even require a return type because it's a loosely typed language. So it's really a piece of trivia knowledge that I think is important to understand to know how we got where we are today, but really not that important from a, can I do my vocation? Is this something I can do in the real world? Because you're always going to be dealing with methods. All right, so step one for this quiz should have been writing that. If I give you something that looks like this, you should be able to write this method header in 10 seconds. The longest part of that should have been coming up with an interesting method name. Okay, because it's very much paint by number. What am I returning? What does it take as input? Come up with a method name if I didn't give one to you. And then you always have the opening and closing curly braces. Make sense? All right, so that's step one. We just built our structure. Now we need to build some logic into it. The logic says this guy should return what this method should do is return true if whatever string I passed it, in this case I named it S, has an even number of characters in it and false otherwise. So now I'd ask myself the question, how many characters are in S? There are s.length number of characters in S. So again, we're drilling that idea that methods take generic inputs. The last several classes have been writing loops that have been spinning through strings, right? Spinning through strings. And each time I've asked you, every single class, I ask you, well, how many characters in this? I sometimes have gotten, we have no idea. But I think we've started to get on the same page of, there's s.length number of characters in there. I don't know what that number is, but it's a number, right? That's how we determine how many characters are in a particular string. S.length in the event that the string's name is S. So, how do I determine if something is even or odd? Well, even numbers are evenly divisible by 2. Odd numbers are not. So I'm going to mod it by 2, which gives us the remainder of integer division. So I'm going to return the value that is whatever the length is, which is going to be some number, mod 2. If 2 went into it an even number of times, the remainder would then be 0. Correct? And that's what I'll return. If the length of that string, when divided by 2, has a remainder of 0, that will boil down to true, and that's what this method should boil down to. True that it has an even number of characters in it. If it had an odd number of characters in it, when I divide it by 2, it'll come down to false. That make sense? So the logic is what we did secondarily. Before we put that in, we wrote our structure to write our logic within. All right, so that's how you would tackle those problems. Just like the hello world type of question I had you memorize before. So you should be able to just right off the bat write a full working hello world program. If I sat you down in front of Eclipse, that should be something that comes very automatically to you now. This is something that needs to become automatic, where you can just take some written words and build a method structure out of it. You're going to still struggle with the logic. Logic is just a time-in thing. Okay, that's the experience side of things. Like, for instance, your homework assignment, some of you probably got it done very quickly, some of you struggled with it. Okay, but the part that you should not have struggled with is writing the method structure part of it. The logic in between is the part that you should be grappling with. Because right now you're fighting this little war between, I'm dealing with a new scary language, Java, and I'm trying to teach myself a new way of solving problems, and I can't get my mind to slow down enough to break this into baby steps. Okay? Every single one of you, regardless of how easy this assignment was for you, struggled when you sat down trying to break this, whether it's this question or the question for your homework assignment, into little tiny baby steps so you knew what to do step 1, step 2, step 3, step 4. Because in our mind, we solve problems as just one big cluster. We're so good at solving those problems, it just happens. Make sense? All right, questions about the quiz? Now, everybody thought they got hundreds in it? No? Anybody leave it blank? Anybody left a blank who didn't want to admit to it? All right. So that was our quiz. Here, I'll put the answer back in there. Okay, homework assignment. What was the homework assignment? Now that I've told you that, I'm sure all you struggle with it. That's just because there was logic. I don't actually remember what the assignment was. What was it?
First occurrence of the letter and remove it from a string.
Got it. Just the first occurrence.
Using index.
Oh man, we should do this stuff in here.
No, look for the key, the API.
Oh, is it my API key has? Oh yeah, it does have sex in it.
Twice.
Oh, this one, yeah, it has it in there twice.
I didn't even see the second one.
Well, now we know who.
I did not generate that. That came from Coinbase's website. Yeah, for those of you who are in the 390 class, the special topics we're doing on cryptocurrencies, this is a Java programmer writing for talking to a external API. So kind of a cool thing. A couple of you were in that class in here. What class is this? 250. Ah, here we go. This guy, right? Remove first occurrence. Let's get rid of all this extra crap first. Oh.
No.
There. Now we have a nice, clean program that we can.
I did the same thing yesterday. Made a whole bunch.
Everything else is just it's all cluttery, right? I did have Nick was asking me this morning if you should, for your own purposes, if you should delete your. I wouldn't. If you have code that works,
I just make new.
use that as your own reference. You know that as you. I've done this a few times, so but I would keep most of your code that you can follow as reference. Don't go and delete your programs. Keep them in some sort of folder that has some sort of documentation in it or something like that, so you can go back and reference it when you are trying to solve a problem that's similar to an old problem. And that's pretty common in industry. I mean, in here, I'm trying to teach you how to program as a generalistic tool. In industry, if you're writing a project, so let's take your mobile apps or something like that, and you have push notifications. Once you solve the push notification problem once in an app, you're probably going to use that tool and apply it to all of your apps. You might modify it a little bit, but you're not going to go back and spend 4 hours rewriting the push notification concept when you've already solved that problem. That makes sense? So save your tools. Some people end up having kind of a collection of kind of interesting, useful tools they put together. So I reference our programming toolbox in here, which is more Java, portions of Java that we know. But as you write your own methods for stuff, you'll also have your own version of those things. And it's kind of interesting. There's and you can go out and check this out yourself if you'd like. There's a website called topcoder.com. I think I've referenced it before, maybe last semester or something. And it's like a programming competition. It would be pretty difficult, I think, for most of you in here, but not undoable. I mean, every week they have 1 or 2 different contests, and it's all online. You just go into this room. It takes about an hour, and there's 3 different difficulty questions. So, the easy question, the one that's worth 250 points or something, would be more in our wheelhouse. Then there's a 500-point and a 1,000-point question. Those are going to get more difficult. And your score is based on accuracy and how quickly you do it. And then there's a period where you can try to break other people's code that are in the room with you, whatever. But what you see in there, where I was getting at with this, is a lot of people, they have kind of their own library of code they've written that becomes useful for them. So what they do is right at the beginning of the thing, they have that copied and pasted from a text document. And because you have to do all the coding inside of their little editor, they immediately just drop in, 300 methods in there that have all these tools for doing things that they might want to leverage because they've written that before. Does that make sense? So those are some things to keep in mind when you're writing your programs. All right, so remove first occurrence is going to take a string as well as the character that we want to remove. And we're only going to remove that first occurrence of that character. So the very first thing I might do is I might determine where the first occurrence of that character is, right? So let's go ahead and create an int maybe called pause. So I'm going to create a storage location, type integer, called pause, and this guy's going to be s.index of C. Now I know where the first occurrence was. If the first occurrence happened to be not there, meaning pause is -1, what should we return? Just the original string maybe? So if pause is equal to -1, just return s. Make sense? Now, if you didn't do this for your homework, that's not the end of the world. I'm fine with you assuming that that character existed at least once. Not a big deal. That's not what I was testing you on. I'm trying to drill some programming logic into you. Stupid things like that, important in the real world, unimportant for becoming a good programmer at this point. All right? But that might be something you threw in there. We'll leave it in for now. All right, so if I'm still here, I know that C exists at least once. Right? It's definitely there, and pause holds the position of it. So what I want to do is I want to return everything from the beginning of the string up to, but not including, the character, the position of pause. And then I want to return everything from that point forward. We learned last time there's two different versions of substring. So can't we just return s.substring 0, pause, and that will not include pause, that's non-inclusive, and concatenate onto that s.substring pause plus 1. Won't that do it? Class method or instance method? How do you know? Static. How do we call class methods? Use the name of the class in which the method was defined. What's the name of the class? HW. So we'll say system.out.println hw.remove first occurrence. We'll pass it our hello for our example. And we're going to pass it L for the character we want to remove. And there's our HELO. Now, if you wanted to assume that the character existed at least once, you could have done it in 2 lines. If you really had your heart set on doing it in 1 line, you could have just replaced every place we said pause with this. So here and here. That would have been less efficient because we were actually doing that whole lookup twice. But if you really had your heart set on a 1-liner, you could have pulled it off. Now, what if I was trying to return an H? Return the H. That should be the empty string followed by LO. What if I was trying to return the O? Not the 0, but the O. Okay. Now, besides the funny aspect of it, the reason I tested it that way is to gain an understanding on how substring actually handles it when we try to do something that's before 0 or after length, s.length. And substring nicely handles those things and just returns empty strings. That make sense? So, solution to the homework was, well, could have been this. It's a reasonable enough solution. Now, I assume many of you probably did it in a maybe less interesting way. Or actually probably a more interesting way. I assume, Largan, you definitely did it in a more interesting way?
No, not really.
Really? I was kind of expecting maybe 50 or 60 lines of code.
No, I didn't drink during this one.
Oh. So let's say that we weren't allowed to use substring. You definitely were allowed to use substring and encouraged to use substring in your homework. But let's just say you weren't. Okay, so if we rolled back to last week and I asked you to solve the same problem, you couldn't use substring, how would you solve the problem then?
Two different strings and add them together.
Okay, what strings?
Well, a string that would be before the first occurrence,
Okay.
and then the string that would be one position after the first occurrence. And add them together.
Okay, so you want to build two separate strings.
Yeah.
Okay, how would you build the first one? So we'll go down your path, and then we'll kind of optimize it a little bit. But let's call this S1. You want to start that off as the empty string because we're going to be building them up. We'll start them off as so S2. Okay, so how would we build our first one?
Well, the first one you would do a for loop, and have int I equal to 0, and if I is less than or equal to the index of L, or yeah, I put in the letters, so I guess you could just do C,
Okay.
because that'll be.
Now, why can't you say L there? Why would it be a poor programming practice to say L there?
Well, because then you have to change it all if you want to do a different letter instead of just going into the first part when you call the method. And
So now it's no longer a reusable chunk of code.
Yeah.
Right? Now it's a chunk of code that always searches for L's. Right? Okay?
So then it would be I plus plus after that because you want to go through the whole code.
Okay, so this is going to start off at 0 from S. We're going to keep going as long as I is less than or equal to s.index of C. So this guy, s.index of C, will give us the first occurrence of C inside of S. So let's say that C lived at bucket 3. So I'm going to pick up bucket 0, bucket 1, bucket 2. This will include bucket 3, won't it? Won't I get it too with the equal sign?
And then I do an if statement after that, and I make sure that the letter is not included in that.
Okay.
So I guess you could just do less than.
Yeah, probably less than is going to make the most sense.
Yeah, but I didn't do that. So
No, I get it.
I added the if statement.
Okay, so we're going to go through from bucket 0 up to, but not including, where we find the first index of C. And each time through, we want to say S1 is equal to S1 concatenated with s.char at I. Okay, so that gets us everything from 0 up to the first occurrence, not including the first occurrence. Right, then you said you wanted to build a second string. Okay, and where are we going to start with that one?
You'll do it at one position later. So you would do the same thing as the first for loop, but you would do plus 1.
Okay, well, similar to the first for. I mean, the first for would start at 0.
Oh, yeah.
This one's starting at index of plus 1. So we're starting 1 after it, correct?
Mm-hmm.
All right, and how long are we going to keep going?
That's not length.
I is less than s dot length. Why is it less than instead of less than or equal to?
It starts at 0 and then it goes up. So
Length minus 1 is the last legal, right? So strings are 0 index. That's why we're saying less than s dot length. And you want to build this up in S2?
And then you return S1 plus S2 in candidate.
That? All right. There's a working solution. Now, do we even need S2 here? If we just look at, couldn't we have just continued to build S here? So we could have dumped S2, built S1 as far as we can go here, then continued building S1 with the second loop, and just return S1. Make sense? Okay. Any other suggestions on how we could have solved this? Go ahead.
you create a letter position integer set equal to the index, and then a for loop, so that int I equals 0, then I is less than s dot length, and then add I plus plus, and then you put an if statement. If I is less than not equal to letter position, then you add to your string your temporary string of where the char is at.
Okay, so you're going to store the position inside of a variable called pos.
And then you have
Then you're going to have a string for your answer, and you want a loop that's going to go through the entire string. But situationally, we may choose to skip something in there, right? So as we're going through the entire string, if I is equal to pos, we want to skip that guy, right? So really what we can either say if I is less than pos, skip it, or we can say if I is not equal to pos, if I is equal to pos, skip it, or we could say if I is not equal to pos, let's keep it. Kind of that same philosophy we've had with rebuilding strings. So if I is not equal to pos, answer is equal to answer concatenated with s dot char at I. Figure out where the first occurrence is, right here. Go through and build our entire string like we usually would with one little condition. As long as I'm not looking at position pos, let's go ahead and keep the character. If I is equal to pos, what do? Nothing, we just spin back up. Make sense? All right, kind of an interesting alternative, kind of along the lines of this. Let's say that I didn't like to say I not equal to pos. Instead, I wanted to say if I equals to pos. I'm going to say do this every time. I'm always going to build up the string. But if I is equivalent to pos, what I really want to do is I want to skip to the next version through my next iteration through my loop. Correct? We have a keyword called continue. What the continue keyword does is it immediately jumps to the end of this for loop, so we will not execute this line, and just goes on to the next iteration through the loop. So continue says, skip the rest of this time through and just move on with the next pass. That make sense? So an interesting new tool.
The toolbox.
That slide's running out of your toolbox is getting too big. Continue. Used within a loop to immediately skip ahead to the next iteration of the loop without executing any additional lines in this iteration. That make sense? Now, while we're at it, I'll go ahead and introduce a kind of a complementary keyword called break. The break keyword immediately exits a running loop, positioning us at the line of code following the loop. No additional lines will be executed within the loop after the break command. So break is kind of a quick way to bail out of a loop. Before we use the break keyword, if we needed to get out of a loop prematurely, we could have just adjusted our counter. So for instance, let's say that we were going through all the characters in a string hello. We can loop through 0 from bucket 0 to s.length, which in this case would be 5, right? And let's just say somewhere in the middle we decided we were done. Well, we could just say set I equal to 1,000. Is 1,000 less than 5? Nope. Done. Or we can use the break keyword that just says we're done. We don't have to play the stupid math game. We're just, this loop is over. For whatever reason, we're wasting our time looping through it again. Maybe we're looking, let's say we're searching through a string. Well, hey, here, we're actually going to write it in a certain way. This will be kind of a fun little exercise, I think. We won't use break the first time, but I will the second time. So we're going to write a method, static int index of, and this guy is going to take a string as a parameter as well as a character, and we want to return the first occurrence, the position of the first occurrence in S of C, or -1 if it's not found. So we're writing index of. But since we're not inside the string class, we can't rely on this being an instance method that knows about the string, so we're going to write it as a class method and have to pass it the string and the char. So we are literally writing a method that is identical to the index of method. Make sense? So this guy is only going to return the position of the first occurrence, or -1 if it's not found. Once I find the very first occurrence, do I need to go on? No. All right, so help me write this code. So I started off by saying, let's write index of. Described it. So the very first thing we did is we wrote the method body for index of. We don't have any logic in there, but we have a structure that, if properly coded, will solve the problem we're trying to solve. At least somebody can call this useless method right now, right? Okay? Now, how do you solve the index of problem? I want to figure out the very first position of C within S. If I give you a string, and I'm telling you to search through that string for a character, what are you going to do? As a human being, we're going to say, is this the character? No. Is this the character? No. Is this the character? You're just going to walk through the string, right? It's not rocket science. Do we happen to have a tool that we use pretty often for looping through every character in a string? Nice little for loop. It's kind of our same stock loop through every character in this string for loop. Okay, what does that guy look like? Let's write that little structure. What's our loop look like to loop through every character of a string named S? For S.length like that. We're going south real early here. Yeah, for int I equals 0. I less than S dot length I plus plus. This is our canned for loop for taking I on a voyage through all the indices associated with a string named S. Right? We see the loop right here because we just wrote it. We see the same loop right here. And if we would have looked at a bunch of the code that I've already erased, we would have seen the same loop in there. If we go here, let's I'm just going to look in some crazy program somewhere and show you the exact same pattern someplace else. Not going to be in there. Here we go. So there's a loop that's going through an array, but it's the exact same structure. This one's going through a particular row in the array, exact same structure. exact same structure. Exact same structure. Exact same structure. There's a lot of code in here, right? All hard programs are made up of a bunch of easy parts. All right, so that kind of goes hand in hand with what we were talking about at the beginning of class today. How do you approach these problems? Start building your structure. You don't furnish a house until you've built the outside. You don't start off by just putting a bunch of couches on the dirt and building the house around it, right? Build up the structures. Build up the things that should be fairly thoughtless for you. We can just write these things. Now we can start furnishing the house with stuff that'll break. But at least we know the external stuff. The walls aren't going to fall down. We hung the TV poorly, but the wall didn't fall down. So the embarrassment stays outside of the neighborhood. Or inside the house, I guess. All right, so here's our loop that will loop through every character in a string. Now actually, this loop doesn't loop through every character in this string. This loop takes I, an integer, on a voyage that if we chose to use that integer, would index all the individual buckets of the string. I becomes 0, 1, 2, 3, all the way up to and including s.length minus 1. Make sense? Only if we apply that integer to pulling a character out of the string or something like that does it even have anything to do with the string. All right, so this is our little human search. We're going to look at the beginning of the string. We're going to start looking at each individual character. And we're going to say, is this the character I'm looking for? Is this the character I'm looking for? Is this the character I'm looking for? I'm going to ask a question. 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 How do we ask questions? If statements. So I'm probably going to have some sort of if statement in here, right? So I want to ask the question, is this the character I'm looking for? How do I ask that question? Well, how do I write an if statement? What's the structure of an if statement? If, opening parenthesis, some Boolean expression, closing parenthesis, opening curly brace, closing curly brace. So here's our structure of a question. Now we need to actually write the question. I want to ask the question, is this the character I'm looking for? How do I write that specific Boolean expression? What do I say? Equals C. So is this char, that is the char that s.char at I boils down to, this is a method call, is char at an instance method or a class method? How do you know? No. Tell me why you're wrong.
I don't know why I'm wrong.
Static or no static has to do with when we're defining the method. Here we're using the method. Now I will tell you, you gave me the right answer. You just gave me the wrong reason. Why is this guy an instance method?
Because it's just being used in the class method, right?
How do we call instance methods? You can also answer how do we call class methods, because that's what I'm going to ask you next.
Use the name of the class in which the method was defined.
Okay, so we call class methods using the name of the class in which the method was defined. How do we call instance methods? Using an instance of the class in which the method was defined. The only thing that's changing is whether it's the class name or it's an instance of the class. Okay? Now we know that char has part of the string class, right? The guy was defined there. Is this the word string or is it an instance of the string class? That's an instance of the string class, S here. So since I'm calling char at with an instance rather than the class name, it must be an instance method. Make sense? All right, so if this particular character is the same as this particular character, are we allowed to use double equal signs like this? Won't that get us into trouble?
Nope.
Why not?
That's a Boolean expression.
Well, we're not using chars.
Okay, why was the double equal sign problematic with strings and why will it not be problematic with chars?
Because chars only one character and strings are.
The strings doesn't look for the same location, not just the actual characters within the string.
Try to give me an answer dealing with what the double equal sign is meant to do.
It's supposed to compare variables.
What kind of variables? Primitive types. Nate.
I was gonna say, strings can't boil down to a Boolean expression by themselves, can they?
The only thing that could boil down to a Boolean expression by itself would be a Boolean variable. But this guy, this operator, think about the operator first. Before we start thinking about what we're trying to do with it. This operator is the equivalence operator. It's the Boolean equivalence operator for comparing primitive type values. Now, we can replace that word primitive with the value of a variable rather than the value the variable points to. Okay? Primitives, we think of them as the value stored within a variable. As opposed to objects, we think of them as holding memory addresses which then point to the actual object. The actual value lives someplace else. The double equal sign was designed for comparing primitive types. Comparing value to value. Not following an address somewhere up here and comparing the actual object. Okay? C is a char. S.char at I boils down to a char. Chars are primitive types, correct? What kind of values do chars hold? What kind of value do chars hold? Go ahead.
Integer?
Ah, I love that answer. Tell me what kind of integer.
Number kind?
Okay, you missed the first trap.
Unsigned is an 8-bit.
I like the unsigned part. We got a good tag team in that row there. So chars hold integers. They are unsigned integers, and they're 16-bit integers. 0 to 65,535. Why that? Why do chars hold integers? We think of chars as being letters and characters and stuff like that, right? Like Z and question marks and commas. Those are chars. But Randy's told us that these guys hold integers. And I'd be the first one to make fun of him if he was wrong. Why do chars hold integers?
Because that's the way that the computer will be able to communicate. Because an integer is a number that can be represented by a binary number, which is some language that the computer reads.
Okay. So computers like storing crap in numbers.
Yeah.
Okay. What do those numbers translate to? Why do we need 65,536 unique numbers for the char primitive type?
Because you got all the letters of the alphabet in caps and all the symbols, and they all are represented by a number.
Okay, and there's 65,536 of those?
I'm sure there is.
Unicode. So prior to Unicode, we had ASCII. American Standard Code for Information Interchange. There was 256 characters in ASCII. That would be an unsigned byte, unsigned 8 bits. So that would give us 0 to 256. So if we were only having to represent the ANSI, I'm sorry, it's not ANSI, the ASCII character set, a byte would be sufficient. Java supports, and most modern languages support Unicode, which has a much less American view of things and a more global view of things, like, hey, there's other languages that use characters other than the American alphabet. Shenanigans. But good news for us is most of our terminals, and as we've seen in our Americanized operating systems, don't support those other characters. So yeah, you could technically represent, some Chinese symbols. But we don't know how to print them.
Put it in binary.
Yeah, that's true. Why can't we all just speak binary?
Yeah, right. Universal language.
Wouldn't that just be so much more verbose?
What would you do? Like 001101?
Yeah, how many of you watch Futurama? Or is it still on?
No,
It's over.
Okay. There was remember there was one episode with Bender. He was doing that. He was in a play. It was a robot play. It was like 11000111. That was like he was reading his lines. Get it? Uh-huh.
They have a lot of those shows. Zeros and ones.
See, I only saw that one. What was I talking about?
Speaking.
Speaking binary. Yeah, we should be more verbose. That seems like it'd be a good waste of time. All right, so this guy uses the equivalence operator to determine if this char and this char hold the same number. Okay, so if I am looking at the same char, again, remember, we're doing this index of problem. Okay, so I've gone through, as a human being, I'm going through every character in that string. If I find the character I'm looking for, what do I do? I heard somebody say print it out. Oh, breakout. Okay. So we're going to do it. Let's call it the right way first, then we'll force a break. He's right. He's doing what I'm fishing for, but really we don't need to break out of this. With index of, what do? When we find the first occurrence, what does index of return? The position of the first occurrence. So we're going to return what? I. That's where we found it. That make sense? So, what does the return keyword do? Makes a method immediately end. Do not pass go. Do not collect $200. Done. Method's over. Make sense? All right. So, we'll return I. If we're still kicking down here, what should we return? That means I looked through the entire string and I never found the character I was looking for. So that's the question here. If I'm a human being reading this, what does this code do? This looks at every single character in the string. Then I say, is this the character I'm looking for? If I go through the entire string and I never answer yes to this question, and I'm still kicking here, which means my loop's over, I've looked through every character in the string, that means I didn't find it. What do I return if I didn't find the character? -1, because that's what index of does. Correct? All right, so there's an implementation of index of. Now, if I want to force this to work for a break, what I'm going to do is at the very beginning of this, I'm going to create an int answer. I'm going to start that off at -1. At the very end, I'm going to return answer. Inside here, if I did find the character I'm looking for, I'm going to say answer is equal to I, then break. Again, if I show you the slide here, remember break immediately exits a running loop, positioning us at the line of code following the loop. And let me actually just, before I'm going to put loop in all caps here. It's kind of a beginning programming mistake that a lot of people make. You kind of throw loops and if statements into one big category that you name loops, or you name if statements depending on which error you're making. So notice that this break is inside of an if statement, right? This guy does not just break us out of this if statement. It breaks us out of the most local loop. So when we hit this break, it puts us right here. That make sense? That's how break works. It busts us out of the most local loop. Now, if you have a loop inside of a loop, it's only going to break you out of the inner loop, assuming the break is inside the inner loop. What's that? Loopception, right. So we started answer off at -1, which is our worst case scenario, right? We change answer if we found something good, and then immediately broke out of the loop. So whatever we return here for answer will be either a -1 or the position we found. See how this is the same logic, just the way we got to it is a little slightly different? Okay. So questions about continue or break. Two new tools we have. Continue skips an iteration through our loop. Break gets us out of a loop. Very important tool. And you're going to use this tool a lot. And if you're in some of my other classes, you've already seen us use this tool. This concept of string parsing. Okay, I'll mention it again that Java is a string-based language, and strings are very, 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 very important in Java. I can make that same comment about languages like C#, and I can make the same comment about languages like Objective-C. So all of our modern languages put a very, very high importance on strings. Being able to work with strings then is a super powerful skill. If we're in the 390 class right now, we've been reading in some JSON stuff, right? A document formatted in a special weirdo way. And we are parsing through that to get the actual meaning out of the document. Okay? If we are dealing with an HTML page, we're writing a web browser. The documents that get served to a web browser are in HTML format, which is an XML-based format. So you have opening and closing tags. And the actual data that's in there is housed within all this extra fluff. So to parse it, you have to pull out the meaning. So parsing is the act of pulling meaning out of a string. So as an example, have we seen parseInt in here? Have we done Integer.parseInt in here? Okay. So I'll teach that to you real quick. Actually, no, I'm not going to teach it to you real quick. Oh, what the heck. If I ever don't want you to use it, I'll just tell you you can't use it. So parseInt, for instance, if I have a string, A is equal to 1, 2, 3, and I do system.out.println A, what's the output going to be? Okay, then I'm going to do system.out.println A plus 1. What should the output be? We had one voter turn out to the polls. 124?
No, 1, 2, 3, 1.
1, 2, 3, 1? Because you tested it? Tell me why you're right. Besides the fact that it worked. Actually, tell me why he's wrong.
Well, when you make a string, it's just a solid string that you can't really change unless you do some more coding. Right now, you just have 1, 2, 3 represented by A when you print it out. So that is just itself, that is unchangeable. When you do A plus 1, you're adding the physical number 1 to the physical string 1, 2, 3.
Why?
Well, I mean,
This operator right here. Tell me about that operator.
it's just, yeah.
That's the plus sign, right?
Yeah.
What does the plus sign operator do?
Yeah, concatenation
Or?
or addition.
Well, he thought it did addition in this case, right? You proved it did concatenation because you cheated.
Well,
Tell me why it does concatenation rather than addition.
because you're doing a string.
Because there's a string on at least one side of it.
Yeah.
So it's how Java interprets this operator. Does it decide that this guy is the concatenation operator, or does it decide it's the addition operator? In this case, it decides it's the concatenation operator because this guy right here is a string. So since it's a string, it doesn't make sense to do math with strings. We concatenate strings. So this first line here is going to print out the string 1, 2, 3. The second line will print out the string 1, 2, 3, 1. What it did is it glued that 1 onto the end of the original string. It concatenated it. Make sense? Now, we have a method called parseInt that takes a string as a parameter and boils down to the integer equivalent of that string. So if I print this out, I'm going to have 1, 2, 3, 1, 2, 3, 1, and then 1, 2, 3 again. Visually, we can't tell the difference between these two lines, right? But I can tell you that this guy is an int. This guy is a string. Because parseInt, integer.parseInt, turns that int into a string. That guy turns that string into an int. That guy boils down to an int. So if I add 1 to that guy, now we get your 124. That makes sense? Because the guy on the left-hand side, well, the guy on one of the sides of the plus sign was not a string. This guy is an int. This guy is an int. So this guy gets treated as the plus operator, math.
Why doesn't it change if it was the char A? If you had a char, why wouldn't it convert it to an integer?
So you mean if I put in,
If string A was equal to A.
I'll just do another one here. Oh, hold on. No, I'm not sure I know what you're asking. You're saying if I did that,
Yeah.
that's an error.
Well, why wouldn't it change it to the integer representation?
Okay, well, I'll give you an extreme example. I'm going to hand you a wrench. I'm going to say you turn this into a number. What do you what would you expect the result to be?
Well, I would weld it.
So if I give you the letter A, I tell you to tell me the value of this. We know as programmers that under the hood there's a Unicode value to it, right? But that's just a mapping thing. That's not something you do math with. So parsing the integer out of a char doesn't make sense. We can convert a char into its integer equivalent by typecasting it. But parsing the int out of it, again, remember, parsing is pulling meaning out of a string. And the string A has no additional meaning other than the string A. But the string 1, 2, 3 potentially is just the string representation of the number 123. Make sense? Now, what I thought you were asking is, what if I did this? What's the output of that going to be? Ah, B. Does that make sense?
No.
Oh, hold on. Look at the error we're getting here. We didn't even get to that line yet. See, another common mistake we make. Beginning programmers tend to see the wall of red and don't look at it. Oh, I broke something. Boom, let's go back and change crap. All right, so let's look at that error. The error was a number format exception. Why? Because we had changed our string to an A. Integer.parseInt no longer makes sense. Let's turn it back into a number. Now we could parse it into a.
Oh, because now it's recognizing a
Why is it 98? Is 98 the Unicode value of A?
97.
Ah, what's 98?
It's the plus one.
It's the plus 1, which would then be the Unicode value of B. And if I wanted to get this as the Unicode value, what would I do? I could typecast that to a char. I could say take the char A, add to it a 1, which will give you a Unicode value we just saw, which was 98. Now turn Unicode value 98 back into a char, which will get us a B. And this goes back to what we were talking about at the beginning of class today. This is no trick. This all has to do with data representation. We like to look at things as characters. Computers like to store things as numbers. The second we just put the char A plus the number 1, what we need to look at here is the plus sign. How is that plus sign going to be interpreted there? Well, is there a string on one of the sides? No string. There's a char, but no strings. No strings here. So that means this guy will not be interpreted as the concatenation operator. Instead, it'll be interpreted as the addition operator. Right? All right. So, given that, what's the char A plus 1? Well, A has a numeric value under the hood because we know how chars work. So we'll get the numeric value of A, we'll add to it the numeric value 1, giving us an integer result. Because addition, the addition operator produces an integer. And that's why we get the 98. Make sense? All right, for your homework, and I'll write this out in Angel, but I'm going to have you write a method that takes a string in the following format. A number followed by, we'll just do it for plus signs only. Keep it simple. Followed by a plus sign, followed by another number. I want you to have that method return the sum of number and number. So for example, if I passed you 13 plus 5 as a string, it should boil down to the number 18. So our first little step at parsing some meaning out of a string. This is more than just an integer, so you can't use Integer.parseInt directly. You may use Integer.parseInt for this assignment, if you'd like. But you're going to have to do some doctoring of this string first. Make sense? Probably getting the first part, everything up to but not including the plus, and getting the second part, everything after the plus. Similar to what we did for homework today.
Do you want to start out with that? 13 plus 5?
Well, this can be anything, any two numbers.
But you don't want us to do like A is equal to 13, B is equal to...
You're going to have a method that takes a string in,
Okay.
and the string has to be in that format.
Okay. Sounds good.
You doing lunch?
Yeah, I'll be right back. I got to pick up a pack.